So it's a really great pleasure to be speaking with Professor Nathan Bindoff, who's a physical oceanographer at the University of Tasmania's Institute for Marine and Antarctic Studies. Professor Bindoff has been a coordinating lead author on the Intergovernmental Panel on Climate Change's special reports on oceans and cryosphere. Professor Bindoff, those are obviously great long reports with input from hundreds, thousands of scientists, but could you just try and maybe just simplify it for us? If you had 30 seconds to a minute to convince me that climate change was something that really demanded immediate policy action, what would you tell me?
So the Earth's already warmed up. It's warmed up between 0.8 and 0.9 degrees. The oceans have already acidified. The oceans have risen. The temperatures in the oceans have changed. The oceans are absorbing all of that excess radiation that comes from human emissions into the atmosphere. And actually about 500 scientists concluded that actually the dominant driver in the climate system was human emissions into the atmosphere. So humans are the cause of the recent climate change since the 1950s, and not only is it 500 scientists saying that, actually 115 to 120 nations actually all agreed in a plenary session where they met and discussed the conclusions of the reports from IPCC. And they agreed by consensus. Every nation actually agreed that agreed with the scientists that the humans were the dominant cause of climate change. And actually we can prove it. We can prove it with the theory around climate change, understanding how emissions into the atmosphere cause radiation to be trapped, gets into the oceans warm up. Through thermal expansion they get higher, the heat is transferred to the poles. Antarctica and Greenland are already observed to be melting and contributing to sea level rise, along with the glaciers around the world. We can measure ocean acidity. You know, if CO2 gets stirred into the surface of the ocean, it's becoming increasingly more acid. And so the big questions in many ways is how quickly are things going to change? What does the future look like if we continue to emit into the atmosphere? What does it look like if we stop emitting into the atmosphere? And these are the questions that society needs to address, right? They're the policy relevant questions. How do we reduce the consequences of climate change for society? And the challenge, in my mind, is actually for society to make those choices. The scientists like me can deliver up the information. We can tell you that Antarctica, Greenland and ice sheets are melting. They're contributing 50% of sea level, 50%. The other 50 comes from thermal expansion. But actually there are some really big questions. For example, if we continue to emit into the atmosphere on a high emission scenario, the kind of scenario that we've had actually for the last 50 years, a natural continuation of that. We call it kind of business as usual. We could have by 2100 a 1 metre sea level rise. By 2300, 2400, a 4 to 15 metre of sea level rise. It's a big range actually. It tells you there's some big dangers that are potential there. So,
and that's already potentially locked in change, isn't it? One of the key findings or the key recommendations for the 5th assessment report of the IPCC, which you were involved in, was to limit growth, limit the increase in global temperatures to 2 degrees. Tell us a little bit about what went into that, and also what the next step is in terms of the next assessment report and your involvement in that.
Okay, so the 2 degree limit's been around for about 30 years. It came out of the United Nations Framework Convention on Climate Change, actually 1992. And 2 degrees was kind of an assessment by policymakers that this was an acceptable level of temperature change. And that first estimate of what was acceptable is still with us today. But the policy question is, what do you need to do to actually meet that level? We've already come 0.8, 0.9 degrees. If we stopped emissions tomorrow, if we stop them tomorrow, imagine a world where we don't emit CO2 into the atmosphere anymore. We've got another 0.4 degrees. So we're at 1.2 to 1.3 degrees with a complete cessation already committed. And in fact, what we need to do is to have emissions actually turn over, decline, and go to zero. Go to zero by somewhere between 2050 and 2070. So there's a little bit of time in the sense that we can continue to emit, but actually we have to turn over this decade. And so there is the challenge. The challenge is for anthropogenic emissions to decline to zero by 2040, 2070, and in fact in some scenarios become slightly negative. So this is a complete change of the way that we deal with carbon emissions into the atmosphere.
In 2014, you were asked about this. You were asked for an online project to handwrite how you feel about climate change. This was a project called How Do You Feel? And scientists from all over the world were asked to write in. One of the things that you wrote in your handwritten submission was that you're optimistic about the potential for humans to come up with a solution.
So climate change affects everyone. You know, it's a threat to things like food security, agriculture production. It's a threat to our natural environment. Projections of climate change show localised extinctions, particularly around the tropics of the world. So it has huge impacts, but it's all in the projections. Society could choose. We can simply choose to transfer to a sustainable world where emissions are actively worked back to zero. And if you bring together things like human ingenuity, a decision by society that's a commitment, a real and genuine commitment to reduction of emissions, then actually we can avoid many of the very significant problems that are in those projections and mitigate most of it. We still have to adapt because we've already committed to at least 1.5 degrees of climate change. So I think it's really just, it's very simple. Society just has to commit and do it. There are solutions, and that's very clear in my mind.
So to make that commitment, what we need is clearly evidence that there is a risk from climate change. How certain are the risks? How certain are the projections?
The projections are reasonably certain, but perhaps more importantly is we've already seen changes in extreme temperatures in the atmosphere, extreme heat waves, and we've become increasingly sophisticated in actually telling you that how much of that heat wave, what fraction of that heat wave was actually contributed by humans. We've discovered marine heat waves, and increasingly we're understanding the consequences of marine heat waves that have already been observed just last year, just off the eastern coast of Tasmania, 50 times to 300 times more probable than it would have been without that change in the underlying temperature. We know, for instance, around sea level, in some areas, a 1 metre sea level rise, not particularly large, will mean a 1 in 100 year return period become 1 in every year. So there are small changes in the natural environment forced by climate change have big impacts on extremes in climate change. And this is why it flows on to things like food security, energy security, all of these things touching society.
Do you think that the issue of climate change has had the level of traction at the policy level that it should have had? Or is this something that you look upon as a scientist and feel a bit frustrated by?
Climate change is a huge issue. If you keep in mind what it means that emissions have to go to zero. That's very threatening for a huge array of industries that we depend on for work, and so of course it's contentious. Of course it's contentious, and of course as a consequence of that it requires quite radical changes in the way that we do our day-to-day business. That's what becoming sustainable really means. But I believe actually that we have the solutions. Climate change is not is not impossible to solve. We can actually, with the right decisions by society, actually mitigate. And I'm more confident of this now than I was a decade ago. A decade ago, it was very hard to understand that renewables could actually deliver the energy we needed. We're more confident that they can deliver the energy we need. And so in some ways, I'm more confident than I was a decade ago around solving the climate change problem. But it's not the scientists to solve, right? It is actually a societal problem, and it has to be solved by the collective of society. And so the contention is very natural, but it is something that needs to be conquered and worked away at.
Do you see a problem with scientists actually getting politically involved? Scientists are some of the most trusted people in the community, still up there with doctors and nurses. Is there a danger that if a scientist such as yourself is seen to be engaging in political discussion rather than simply sticking to the science, is there a danger that scientists may erode their own credibility? Can that be counterproductive?
Maybe you're making a statement that scientists cease to be scientists and become lobbyists. The challenge for scientists is actually to remain in the sphere of science. Science is about testing the hypotheses, bringing forward the information and distilling down the measurements to tell us about the trajectory of the Earth. That's what a climate scientist is about. And that is exactly their business. It's really important actually that they're responsive to society. You know, they can answer the questions like, what does it take to meet the 2-degree threshold? What does it take to protect the Antarctic ice sheet or the Greenland ice sheets from further erosion? Can we make decisions about the way we might respond that will minimise the changes? Can we adapt? And it's that kind of information, those sorts of scenarios, if you like, that scientists can deliver for the benefit of the community and for the benefit of decision makers. So the challenge, in my mind, is just simply for the scientists to provide the information. So that's what they should be active in doing. It's for decision makers and the society as a whole to commit to the sorts of implications of that.
So what you're describing then really is an interdisciplinary challenge. You're involved in a conference in February in Hobart, Imagining a Different Future. Do you see a role for many different disciplines in addressing some of the policy challenges around climate change right now? It's not just a question for science, is it?
It's not just a question for science. The science goes to a certain distance, provides the information, tells you how to respond. But actually, how do you actually turn those into institutionalised decisions that actually guarantee equity for the society, justice, future generations, preserves our economic well-being? How do you actually include all of that? And that is perhaps the stumbling block in our current action plans around climate change.
Professor Nathan Bindoff, it's been a real pleasure talking to you. Thank you.
Thank you.